Hello, Mr. and Mr. Reiner, right?
Yay!
This is a rectangle.
No, it's not.
Oh no, this is a square actually.
Is it?
Square, so this is 90 degrees each
Yeah,
corner.
obviously.
This side is 1, 1, 1, 1. This side is 2, 2, 2, 2. Okay? So guess what's the question?
What's the size?
Of which one?
The small square, which is slightly
Okay, yeah, that's good.
diagonal to
So how do you know this is a square?
because all the sides.
Well, it's not square, it's just wobbly.
Because look, all of these are the same. Like 1, 2, 1, 2, 1, 2. These are the same. They're
Yeah,
identical.
yeah,
Even
identical.
with the angles are the same.
These are the same. Look, these, right? And these, right? This is 2, this is 2, this is 1, this is 1. And this angle is the same as angle. So these two triangles are identical. So that means this angle is the same as this angle. Am I right? This angle and this, right?
Yeah.
This angle plus this angle, how much? If in this triangle, 90 degrees. Am I right? This plus this is 90. And I'm just saying this is equal to this. Am I right?
Yeah.
So this plus this is 90 degrees, right?
Yeah.
So 100 minus 90, this is 90. Okay? You're right, yeah?
Yeah.
But this angle is not the same as this angle. This angle is the same as this angle. Make sense?
Yeah.
Yeah? Look.
Yeah. Yeah, but I'm saying like if it was 45, then that is 45, and then that one will be 45.
That's not 45 because this is 1, this is 2. If
It is
45,
that's 45 in my brain.
if it's 45, in what cases it's 45? This is 2, this is 2. So it's in the middle. In the middle, then it's 45, right? Because in the right triangle, this is right triangle. If this side equals this side, then this is 45 degrees. Am I right? Okay? But if this is not the same, this is not 45. If this side is not equal to this, the angle is not the same. These two angles add up together 90 degrees. Okay?
Yeah.
Okay, very good, very good. Okay, we have to ask ourselves, why is it square? Okay, so you prove your point, this is a square. Okay, so we want to calculate the size of the square. So what's the strategy?
So you need to figure out the area.
Yes, the area.
So you need to find out. You need to find out this line, so you can just basically count it by 4.
Okay.
But to find out that line, you have to find out the triangle. Like here, you need to find out this line.
Okay, so actually there was a mistake. Because this is too easy, right? If I'm saying that this is 2, this is 1, I can get this, right?
Yeah.
This is A, this is B, this is 90 degrees. What's this? If this is C. If this is the right angle, this is A, this is B, this
There's
is
no
C.
such thing as a right angle.
90 degrees, what do you call 90 degrees?
You said right angle, not right angle.
Right.
You said right.
Okay. A, B, C. What's this C? Remember, A squared plus B squared equals C squared. Yeah? This is very important. Yeah? If this is 3, this is 4. What's this? 5. Yeah. Okay. Remember that. Very, very important.
Okay.
Okay.
What's that? That's not a straight line. Are you confident?
No, it doesn't look like.
Okay. So let's remove the black lines. Okay.
How about that point to D?
Wait. Yeah, you're right. Yeah.
The point to D.
Which one?
The
Yeah.
D connected to something.
Okay. So is this still a rectangle? It's slightly different, right? Previous one that was easy because you can use this, get this side. If this C, the square will be C square, right? That's the area of that square. But for this one, is this a rectangle?
You have to prove something if it's a rectangle or a square. Now to prove if it's a rectangle, you need to prove that it has a right angle on all of it.
Yeah. So do we know this is this a 90 degree?
This is a right angle
Why is this a right angle?
because it's a triangle and it's like this.
How do you know this is a right angle? This is the thing. How do you?
I can visually see it.
This is mathematics, but the way you see it, you need to prove it. Okay, so we don't know. Maybe, this is the homework for you today, okay?
No, because this is half. This is half
Why is it half?
because it's half.
No, it's not half. It's not half.
What is
The
it?
only thing you can do is that because this is 1, this is 2, the whole side is 3, right? This is 1, this is 2, this is 1. So this is 3, 1, this is 3, 1. So these two triangles are still identical, right? It's the same, still identical, alright? So,
It's just split up.
yeah, but so what does it mean? So it means that this
See?
angle is the same as this angle, right? Yeah? So this angle plus this angle is 90 degrees.
See?
So this angle plus this angle is 90 degrees, right? If it's 90 degrees, this is the angle, right?
Yeah.
I just prove it. Got it? Look.
You don't get it.
You don't get. Okay. Look at this. This
Yeah.
this triangle, right? Is it the same as this triangle?
Yeah.
Because this side is 3, this side is 3, this side is 1, this side is 1, right? And this is the right angle, this is the right angle, right? Yes? This angle is the same as this angle, right? Yeah? Make sense? Okay, so this angle plus this angle is 90 degrees, am I right? This small angle plus this small angle is 90 degrees, am I right?
Yeah.
I just said this angle is equal to this angle, am I right?
Yeah.
So this angle plus this angle is what?
90 degrees.
If in a triangle, if two angle plus 90 degrees, what does it mean? The third angle is 90 degrees, right?
Yeah.
So this is 90 degrees, right?
Yeah.
Okay, so this is 90 degrees, this is 90 degrees, this is 90 degrees. The same, right? The same because I can prove it similarly.
How do
Okay?
you know the angle inside the rectangle is also 90 degrees?
This one, yeah?
Yeah, how do you know the one inside?
Okay, because this is a straight line. If one of the angle is 90 degrees, you just said this is 180 minus 90, this must be 90.
Yeah.
Okay, we want to calculate this area, the size. So your strategy is calculate this side, right? Yeah?
Yeah.
That could work, but what's the other strategy? Because it's hard, maybe hard to calculate this side, right? If you calculate this is c, then c squared. We want to get
Do
this.
you do something with the numbers?
No, just forget about the number. I will just say, we want to calculate this. How many ways we can calculate this? One way, which is very good, is calculate one side, because this is a square, right?
Yeah.
Is it the square of the rectangle? Yeah, we have to prove it's a square, obviously, right?
Yeah, because the numbers outside prove us.
Because mathematics, you have to be very, very accurate. At the beginning, I don't say it's a square. First of all, you have to prove it's a square, right? In order to use these, right? And this is a square, right? And each side we know. So we know the size of everything.
Yeah.
And we know the size of everything. We just have to get rid of the outside. Do the subtract. Make sense? Okay, so how many triangles we need to subtract? There are 4, right? Look. Which triangle we need to subtract 4 times? Is this one. This one, 1, 2, 3, 4. Am I right?
Yeah.
Right? So we just need to figure out this triangle, right? The size of it.
Yeah, but if you can, that's basically doing the same thing because you have to figure out the triangles.
Yes.
You have to figure out the triangle to subtract it. So basically it will be as easy as you're figuring
Yeah,
out the
okay.
side.
It's
So-
pretty similar, but this is the opposite, right? You're saying calculating this, which is nice.
Yeah,
I'm
but-
saying I want to calculate this side, and I will do this.
Yeah, if you want to calculate that triangle, you need to subtract it.
Okay.
So you have to figure out the triangle as well as in the other method that I was saying.
Yeah.
You're figuring out one side.
That's right. Okay, so the answer is SABCD, the whole thing, minus 4 times this small one. Let's say this is E, okay? 4 times SABE, right? SABE is this one, right? 4 times. Does it make sense? This one is 3 times 3, 9, right? Yeah, we know that, right?
Yeah. Yeah.
This triangle, ABC. This triangle, DEF.
It's just bigger.
It's just bigger. Similar, okay? If I'm telling you the angle A is the same as angle D, the angle B the same as angle E, then these two triangles are similar. What's similar? So you just shift it, transition. Or you rotate, right? You rotate. Right? It could be flipped.
It could be mirrored, you're saying.
Oh yeah, flipped or mirror, okay? Or Another way is scale, right? You make it bigger or shrink it. This is called similar triangle. If two triangles are similar, if AB to DE is K, right? If this side divided by this side is K, if this K is number, okay? So we know that all the corresponding sides is K. The ratio is K. And the angles, corresponding angles are the same. Angle B is the same as angle E. The angle C is the angle F, right? Or even the medium. If I pick the middle of one side, this is M. Pick the middle of one side, N, okay? So this is called the medium. AN divided by DM is also K. How about the size of ABC area divided by size of DEF? What's this? If it's similar, this is too similar. So what should I put here?
Is it something to do with K?
Yes, of course.
What's it?
The size of the ABC is BC times this height, right? Times this height. The size of DEF is DE times this height. This is K, this is K, this is K, this is K. So times together K squared. Okay? Yeah? Okay, this is called similar triangle. Okay? So similar triangle, there are a couple of ways to determine two angles. Angle. If there are two triangles, two angles are same, they are similar. If three sides are proportional or the same, then they are similar.
What?
And another one, if two sides and then corresponding angle are the same, then they are similar. For example, look, this is a triangle, right? If I draw a parallel line, okay, this triangle, this angle is the same as this triangle, this angle. This angle parallel, right? This angle is the same. This angle is the same as this. So this triangle is similar to this triangle, okay? This angle is the same as this angle. This side to this side is the same as this side to this side. Then these two triangles are similar, right?
Yeah.
How about SSA? This is not. So these two are obviously not similar, right? This A here, this B, this C, this D. And this angle is the same. This angle is the same, okay? This angle, yeah, this angle is the same, but A to C is the same as B to D. This angle is the same as this angle. They are obviously not similar. Make sense?
It's just like the top part is the same.
Yeah, look at this one. I can rotate these. There's a possibility this angle, right? This angle is the same. So if I'm just saying, look, for example, here, right? I can put it this side. For example, let's just compare when they are equal, right? This is the same as this, right? And then I'm just saying this angle is the same as this one. So look here, right? I can put it here.
Yeah, but then, but wouldn't this line have to get bigger, longer? I mean.
I can just put it here.
Yeah. Yeah, but the bottom line is longer than the.
The longer?
Is longer.
No, it's no longer. It's the same. It's the same. Look, it's just like that. Yeah. Yeah. I just put it here.
But what if you do like, meow?
Yeah. It's possible to find these, right? To the center, right? It's geometry, right? So this is not, right? This just these three cases, right? Okay. And there are more. You know, if you have a right triangle, what do you call the triangle with the right angle? What do you call it?
A right.
Isn't it an equilateral? Or
No, right.
A right angle triangle.
Yeah.
Right angle triangle. Okay, if there are two right angle triangle, if one of the angle is the same, then obviously it's two angles, right? That are similar. If okay, this is a special case. If one side, the longest side, and one of the other side are proportional, they are similar. Identical triangles are similar, right?
Yes.
Identical triangles are similar. Okay. So we want to find out this, right? These two triangles are similar, right? Similar, right? They actually are identical. Identical triangles are similar. I want to calculate the area of these, right? At least I want to know this and I want to know this, right? Because this is the right angle. If I know this, I know this, I know the area, right? If a right angle triangle, if this is A, this is B, the size is A times B divided by 2, right? Yeah? So I want to calculate this, I want to calculate this, right? So we know this side, right? Longest side, right? This side. This is let's put it F. DF. What's DF? DF is it equals to look at this triangle okay? DF, right? This is D, this is F, right? So this side is 1, right? We know, right? Yeah?
Yeah.
AD. This AD is 3, right?
Yeah.
So this side we know, right? A squared plus B squared equals C squared. So A squared 9 plus 1, 10. 10 squared. So this one is square root of 10, right? DF is square root of 10. Does it help?
No, not really.
This is G. AG.
Yeah.
We want to calculate AG and GD, right? AG and GD. Okay. AG and GD. This triangle, right, is similar to this triangle. So this as to this.
And that is similar to that.
Yeah. So it's the same, right. This to that is similar to
This to that.
3,
To
right? To this, right? Yeah.
no.
So equals 3 to this. This is the longest side, which we just get it, which is the square root of 10. Okay. So we can get this AG. What's AG? AG is 3 divided by square root of 10, right? Okay. Now we just need to calculate DG, right? But look at this triangle. This side is 3, right? This side is 3. And AG 3 over 10, right? 3 over 10, square root of 10. And I can get this, right? This is 3. This is 3 over square root 10. What's this side? 3 square minus this square equals 9 divided by 10. So equals, this is 9, right? 81. 81 over 10. 81 over 10 square root, okay? So what's this? Is square root of 10, 9, right? Okay? So this side equals this. So DG equals that. Okay, AG equals what? This, right? So what's the area? This times this. Divided by 2, right? Square root of 10 times 10, yes. 10, 27 divided by 2.
13.5.
20. Okay? And I need to times 4 times, right? Times 4 times. Makes sense because this is just 1. I need to times 4, am I right? So this is 27 over 5.
Is 5 2/5.
5.4.
Yeah.
Okay, 5.4. The overall is 9. 9 minus 5.4.
3.6.
3.6. Okay, this is the answer. The area, this side is 3.6. Okay, so to sum up, we want to calculate this bit. First of all, we need to prove this is a square. How do we prove this is a square? I just tell you, right? Because this triangle is the same as this triangle. So this angle is the same as this angle. This plus this is 90 degrees. Therefore, this plus this is 90 degrees. And in this triangle, two angles added up 90 degrees. So this must be 90 degrees. So this 90 degrees because it's straight line. So this must be 90 degrees. And I can prove using a similar way. These are 90 degrees, right? Your approach is to calculate this bit, right? Which is alright. My approach is to calculate one triangle and multiply 4 times. 4 times and subtract from the entire square, which is 9, okay? So how do we calculate this? We want to know this side and this side, right? Because for a given triangle, if this is A, this is B, the area is A times B divided by 2, right? How do we get this side? We use a similar triangle, yeah? We talk about similar triangle. Two angles are the same, similar. 3 sides are proportional, all the same, similar. 2 sides and their corresponding angles are the same, similar. Okay, this is the base 3 cases. Okay, and identical triangles are similar. Okay, and using that we can do this equation, right? This side as to this side, right? Because it's the same, right? This side to this side is the same as this side to this side, and the longest side we know this equation, right? This is A, this is B, this is C. 90 degrees. So A squared plus B squared equals C squared, right? So once we get this side, now we can use the same thing. We know this C, we know this A, then we know this B, right? Because C squared minus A squared equals B squared, right? And then we squared it. Okay? What have you learned today?
About finding the area.
So we're learning about this this square, and there's a smaller square inside it too, and we want to find the area of that smaller square. So to find out, your approach is to find a area of a triangle on the outside of the smaller square and times it by 4 and subtract it from the area of the whole square. We know it's a rectangle as the square the corners is obviously 90 degrees, and that corner where A is, and the triangle A to F, A to G, that smaller triangle, is identical to the D to 1. So we know that those two is 90 degrees. And then since there's a straight line down from A to there, it is a straight line. So we know that it's 90 degrees. So we know that's a rectangle. A square is a type of rectangle, just special.
That's good. Thank you. Bye bye.